All right, so we're going to actually skip the warm-up questions just because of our tour delay schedule and go straight into some of our theorems. Now, the theorem we're learning today, you actually could probably solve without it because they will look like actually a question on your quiz. But the side splitter theorem tells us if we have a line or a segment that is parallel to one side of the triangle. So in this picture, you can see that RS is parallel to XY. And it has to intersect two sides of the triangle. Then it will divide the sides of the triangle proportionally. So you actually had a question like this on your last quiz where you had to set up proportions doing like small over large and small over large. The side splitter theorem actually says that this will split the sides proportionally. Okay, so I have if RS is parallel to XY, and this side splitter actually creates the proportion for you. It'll be QR over RX equals QS over SY. So if you actually extend this, like you'll have numbers here, it'll just be 2 over 3 equals X over 6. So it actually writes the proportion itself. It does have to be parallel though. So if it's not parallel, you cannot use this theorem. So it's important to know that. And this is because you would be able to prove the triangles were similar using AA and all that stuff, but this is kind of a shortcut theorem. So we notice in example 1, we do have that they're parallel, so we can use the side splitter theorem. Again, if you extend the side past where the triangle ends, the sides are, it'll write the proportion for you. X over 16 equals 5 over 10. And then you can cross multiply, or you could probably figure out maybe what it is going to be, but we will cross multiply here and get 10x equals 80. Divide by 10, and we'll get x equals 8. Brett.
Do you have a completed copy of this?
They're on Google Classroom. All of them.
I can't use my notebook.
And I will print them out for tomorrow.
Hmm?
I will print them out for tomorrow.
Okay, thank you.
I may have one over there. I can look. Now, if you chose to, you could solve this like we used to. So you could actually do x over x plus 16 equals 5 over 15, x over the whole thing, and 5 over the whole thing. If you wanted to, you will get the same answer. But this would be obviously a little bit longer with distributing and all that kind of stuff. So that's why this side splitter theorem is useful. See if you guys can try 2. Oh, they don't tell us they're parallel. But they do tell us that both of these are right angles. So what does that mean? Corresponding angles. Good. If corresponding angles are congruent, then lines parallel. So you can use one of those converse theorems to prove they're parallel, and then you can use your side splitter theorem. And you will want to make sure that you group that x over, or x plus 1.5. Go ahead and see if you can cross multiply and find the value of x. You should be getting x equals 1.5. Again, just make sure that you distribute. Some of you forgot to do that. You would distribute it to the x, but then you didn't distribute it to the second term on your quiz. All right, the last one is just going to be a little bit harder to, we'll actually have to come up with an expression for part of the side. Oops. And I should have, let me tell you that these are parallel. So add these markings in. Otherwise, we wouldn't be able to use them here. So again, the side splitter theorem is that if we extend the side, we would say this over this equals this over this. But the problem is we don't know what this is. Can we come up with an expression based on what we're given as to what MC would be? How long would MC be? Okay? good. If you know the whole thing is 21 and you want to take x away, that's 21 minus x. So you had to come up with this expression using what you were given. And then you can write your proportion. Now it's a little bit sideways, but it would be 21 minus x over x equals 10 over 4. Just for the sake of time, we're not going to finish that example. You will get x equals 6 if you cross multiply and solve. But I want to make sure we get to a couple on the back. 2. So on the back, they have a corollary, which is like an extension of the side splitter theorem, which basically just says if you don't have a triangle, but you do have 3 parallel lines or more, you could have 4, and you have 2 transversals that are coming through them. So if you have 3 parallel lines intersected by 2 transversals, then the segments intersected by the transversals will be proportional. So it's basically the side splitter theorem just without the triangle in the picture. It's kind of forming a triangle if you were to extend it, but you would end up with A over B equals C over D. So they're proportional in the same way. So this one says if, again, you have to have 3 parallel lines, 3 or more. L is parallel to M, which is parallel to N, if you see those little letters at the end. Then A over B is equal to C over D. You just have to be careful because sometimes they do flip the picture, like our example below. So this one, the parallel lines are going up and down. So you may want to rotate the paper so that they're going horizontally so that it looks more normal to you. And this one has 3 transversals. You only want to look at 2 at a time. So maybe focus on those 2 first. We would have 16.5 over y is equal to 15 over 26. Again, this acts as a fraction bar. So 15 over 26 equals 16.5 over y. Then you would cross multiply that, of course. Who thinks they know what the second proportion I would write to solve for x would be? No?
15 over x is equal to 46 over 30.
That works. You also could do x over 30 equals 15 over 26, just like the way I set up the other one. But this will get you the same cross product. And then this one doesn't get us a nice decimal. So since this is coming out to be some crazy decimal that doesn't terminate, and we're not asked to round, we would want to leave this as a reduced fraction. So this is 450 over 26. Now to reduce the fraction, you're just dividing the numerator and denominator by a common factor, which since they're both even, they're going to at least be divisible by 2. So that's a place to start, or you can use your calculator to help you reduce for you. But this is actually as far as it goes. We'll get 225 over 13 as our reduced improper. If you want to change it to a mixed number, you can, but improper is fine. Okay. I don't think we're going to get to the last examples, so I'm going to stop there. We'll finish them tomorrow.